All right, here's the 4.8 homework on antiderivatives. I don't have too many comments on this one. I think most of them you'll be able to figure out on your own, but I do have a few things that hopefully will make life a little bit easier for you. So the first question should be fairly straightforward. They give you a function, they ask you for the antiderivative of that function. So just kind of one step where you're calculating the antiderivative. The function they gave you has four different terms. You can kind of deal with each term individually using a power rule. If you do this and follow all the steps we did in the videos, you should get some answer and then a plus c at the end because we're looking for the general antiderivative. But note that they put in the plus c for you right here. And I tried to only pick problems where they did that throughout all the homework, not just this section, because that little plus c thing can be really annoying if you forget it. And some computer programs can be picky, like, oh, I meant capital C, not little c, or weird things like that. So note that you won't type in the plus c. You'll just type in the numbers and the letter x, and hopefully that'll go relatively smoothly for you. Second question is kind of the same idea, except now you might have to do some algebra before you can apply the power rule, namely on these three terms. I don't think we have any rules that deal with them exactly the way they're written, but maybe you can rewrite them and take care of them. Third one and the fourth one are both kind of the same flavor. I think if you figure out one, you'll be able to figure out the other one. It's not algebraic manipulation that you have to do. It's recognizing, man, how do I say this without just telling you the answer? I don't think inverse trig. Maybe that's already telling you too much. That's question 3 and 4. I think you'll be able to take care of those fairly easily. Question 5 is similar to some of the ones above, but be careful. You see this and you're like, oh yeah, 2 times x to the negative 1 power. I'll apply the power rule. Remember, this is the case where the power rule does not apply, so there'll be something else you'll have to do there. Over here, you see secant squared of t. Okay, so first of all, they change the variables from x to t's. They do that occasionally on the homework. I think this is the first one. But don't let that trip you up too much. Just when you write your answer in, write your variables as t's instead of x's. The second comment here, secant squared of t was an answer from Calc 1. There's the derivative of something is secant squared. I think I went over these in the videos. Hopefully you can figure out what that is. The other thing that's new on this problem is there is no plus c here. You're like, oh, I type in a plus c? No, because they don't want the general antiderivative. They want a specific antiderivative because they give you some information here about the antiderivative. So maybe you can use this information to solve for the value of c, and that's why there's no plus c listed on this problem. And that same thing happens on question 7. You have to solve for the value of c. They don't put a plus c here, but fortunately they give you enough information so that you can solve for that value. Otherwise, question 7 is pretty similar to one of the ones above, the second one I think it was. Question 8 and 9 are a little bit different in that they give you the second derivative of a function, and they ask you for the function itself. In both cases, they give you enough information to solve for the two different constants, c and d, in the language that I used in the videos. So hopefully you can solve for those two values. They're a little bit tedious. I think 8 isn't too bad. Tedious is probably the right word to describe it. 9 is a little bit harder, though. You could argue 9 is unfair, because for 9 here, this specific term might cause you a little bit of trouble. I haven't showed you how to solve this. Later on in the class, we'll learn a method for dealing with things like this, but we don't know that method right now. However, I think that in this case, I can leave this problem on here. I think if you play with this a little bit, you'll be able to figure it out. So maybe my advice to you is try just taking the derivative of e to the negative 3x power and see what you get. You'll have to use the chain rule, see what you get for that derivative. And then when you get that derivative, be like, all right, so I'll have to mess with that a little bit because that derivative that you'll get won't be exactly 9e to the negative 3x, but it should be pretty close. So maybe once you figure out the derivative of e to the negative 3x, you'll be able to tweak that a little bit, and that'll help you figure out what the antiderivative of 9e to the negative 3x is. And then they give you this information, and you could plug in to solve for the values of c and d. And remember that e to the 0 power is just equal to 1. And then finally, question 10, the extra credit one. Maybe 9 should have been the extra credit because of that little trick in there. But I made 10 the extra credit because 10 is kind of an application of this stuff. And we're going to do lots of applications of this stuff in the second half of the class, so we really don't need to do them now. But I figured I'd put it in right now because it'll help explain a concept in the next video. So the idea here is, maybe you recall from Calculus 1 that if your function tells you the position of something, then the derivative of your function tells you the velocity of that something. And the second derivative of your function tells you the acceleration of that something. So often it's a particle. In this case, it's an object moving in a straight line. They give you all this information, and essentially it asks you for the velocity and the position, and they give you the acceleration. Maybe you can think they're giving you the second derivative, and they're asking you for the first derivative, and they're asking you for the function itself. And you're like, oh, okay, I can get those, and there'll be like the plus C and the plus D's in there. They give you enough information in here to solve for what both C and D will be equal to. This statement here about the initial velocity being 50 meters per second, that's telling you V of 0 equals 50. So hopefully that can help you. And then down here, the question's asked in kind of a tricky way. It says the position of the object after t seconds is, and then you figure out what the function is from the starting point. That from the starting point is telling you that at time 0, the position is 0. Right? So the initial velocity is 50 and the initial position is 0. And maybe you can use those as statements to solve for both the C and the D, the two constants that you'll get when you take the antiderivative 2 times. Hopefully that makes sense to you. And as always, if any of this doesn't make sense and you need some help from me, just let me know. Good luck.